Hello everyone, this is Shravan Kumar Manthri. Welcome to our channel CSE Gurus. Now we'll see the programming where how to create a node in the circular linked list, insert node at the beginning, ending, delete node and delete node at the beginning and end, and of course we need to display. Of course here I'm ignoring the constraint of inserting node at a particular position, delete node at a particular position, which of course those two are very similar when you go for single linked list or double linked list. What we have done, inserting at position and deleting. Why? Because some position where it has to do nothing with that, so that's why I'm ignoring that part. If you want, you can see the same thing there and you can get the answer, unless until it's not a last position, it's not a first position. Now anyway, instead of explaining with the two programs by taking single and double, I'll go for double linked list, where I'll try to write the program for each and every function for this. So I'll take this one, circular double linked list concept, and I'll explain. And one more thing you remember, like when you take circular linked list, you won't find any null values. Nowhere you will find the null value. Why? Because previously it is single means where is the last node, where is the next node means you won't find the answer. But here in the circular, for last node, what is the next node means first node. So everything is connected. So there are no null values in the circular single linked list and circular double linked list. Remember this point clearly. Now we are going to the programming. So I'm writing from the starting. So anyway, I'm writing hash include stdio.h. So anyway, circular double linked list I'm going. So those who are listening to this, please go through my videos on double linked list and single linked list, so that you can easily understand this part. So into data, I'm going for the double linked list. That's why I need to make it a self-referential structure where I have to take two values. One is previous, the other one is the next pointer. Of course, a pointer where it will store the address of the nodes. Now anyway, I need struct. We need two nodes, which is head node, which is initially null. Okay, and once you construct a circular, you won't find any null values. Initially list is empty, that's why I'm taking null. And of course tail node which is equals to null. Of course the mistakes here, it is assignment only, and here pointer. So like this we need to write initially the list is completely empty. Now I'm taking the options from the user. I'm writing the same like whatever I have written in the single and double linked list. So the choices for the user, from the user, I'm asking printf enter your choice. So the user wants to enter the choice. So scanf, first thing I need to give the choices printf. We'll start with option 1 to create a node. So create. Option 2, insert at begin or starting point. Option 3, display. Of course option 4 for exit. Anyway, I'll write in the next line. Anyway, I'll execute. I'll extend this one. Option 4 is for exit. So as of now this one, and of course we need to write while 1. Every time this has to be repeated, while 1. You have to start this one, enter your choice, and we need to write switch case. Of course scanf to read it from the user, %ld comma %ch, which is a choice. Now switch case with the choices, whatever the choices we have. According to that we need to write each and every case. Case 1, of course case 2, case 3. Initially we want to write 4 cases. Anyway, case 4 is for exit. I'll write it immediately, exit of 0. Now going to the first one, case 1, where you need to enter what is the input value. According to that, creating the node in the circular linked list, printf. A little bit changes you can find here. Enter value. So after that I want to give the value here. Of course the variable value to be declared %ld comma ampersand value val. Once it is done, I want to create a function called as create with respect to the value. Then once it is done, break. The variable val has to be declared here. We declared the value. Now I want to implement first what is this create function. So I'm writing here void create. So I told you, like, create means whatever it may be. If it is empty, it will create the circular linker list with that node. If it is already exists in fresh, that means whatever is there completely will be erased and it will go in a fresh linker list. Now when you create, what is the first thing you need to check it out? Anyway, list is completely empty. I'm writing here. So if I take like this here, so that means initially the list is empty. We know that head equals tail equals to null. So now we created a node with 100 address, value 10. Now if I connect this one like this, so your head equals to this nn, which is a new node. Of course tail also equals to nn, same thing. And also one more thing we need to remember, as it is a circular linked list, anyway initially they are null. As it is circular linked list, there is only one node. That's why this node to itself it should be, right, the address. So that means what is the next address of this? The same node address. Previous is same. Why? Because it's something like a self cycle, self loop we call it as. That means only one node is there. So that's why. So what is the next of this node will be the same node. Previous will be the same node. Why? Because there is only one node. So that is what you can make it here. Here I am creating first of all a node, struct node, what is that, node nn, and I need to provide the address for this. Nn equals to, of course, the same thing like type conversion struct node *. Then using malloc I am creating the memory, starting with that how much I need, size of struct node, how much it is. The same thing will be done. Struct node, how much it is needed, so that much it will be taken. Once it is done, anyway you have to create it nn of data, which is equals to initially x, and of course you can write nn of next is initially null, and of course that is, of course these statements are not exactly required. Anyway we have to update it. Nn of next is null, but for the clarity I'm writing initially how you have to create nn of previous, which is also equals to initially null. Okay, once it is done, now you need to start the process. Once you create the node, you have to connect with this. So when you connect, your head is equals to tail is equals to the same thing, which is nn. Head equals to tail is equals to nn. Now once it is done, now what is the head of previous, that is nn of previous and nn of next has to be updated, right? So that's what here you can do. What is the current node? Head is equals tail equals to nn. Anyway you can write head of previous or tail of previous or nn of previous, all are same. Why? Because head equals tail equals to same. So that's why can I write nn of previous or head of previous, whatever it may be. Head is anyway you updated, head of previous is equals to nn, head of next, of course that is also is equals to nn. All are same in this case. Why? Because you make it null initially you created, and then what is head? 100 to the previous, this address same. What is the next? Same address. So that is what we have done here. This is what creating a node initially. Very simple, you can make it like this. Now after creating the node, the next one is insert node at the beginning. Anyway I is missed here. Yeah, insert node at the beginning. Let us go for it, how to make it a node at the beginning. Of course I need the value. I'll take it here. I'll copy this one, Yeah, enter a value. I'll enter the value according to that. Insert at beginning. Now we need to get this one. How you can make it? Insert underscore begin. How to get it? So at the first, anyway, again I'll check it out with the same constraint. What if the list is empty? That is what first I need to make it. So I'm going for here void insert underscore begin with respect to our value x. Of course, value val same like that is the actual parameter. This is a formal parameter. You can create like this. Now you need to copy this one first. Anyway, we need to create it. Everything we need to create a node. We created now. Now checking the same thing. If head is equals to null means what? So list is empty. See, when list is empty, then only you will find null. Otherwise, see, everything is connected. You can see we updated in create previously. There is no null here when you have even one node also. Okay. So when head equals to null, now whatever the node is there, with that you need to execute create function with respect to that value. So this is fine, and else if not, what you need to do? So you want to write the logic here. What if at least one node is there in your linker list? Anyway, I'm writing here what you need to make it. Let us suppose it is a node we have, and here nodes are there, and here one more node is there, and here I'll take one more so that you can understand clearly. Now this is 100. Let us suppose 100, 200, 300. So here 200, here 300, here previous node 200, here previous node 100, and here previous node. Of course, it is a circular linked list. Here it is 300. Here it is 300. Why? Because the address of the last node. And what is the address here? It's the last address of the first node, which is 100. Now this is the arrangement you have. Might be some values like 5, 4, something like 6. The values are there. Now I want to insert a node at the beginning. So that means this connection should be established like this, and here it should go like this. Is it that much easy? Let us see. So this connection to go out, and it has to establish this one like this. Let us see how we can establish. This is the first node. That means first thing, this is a new node, value something, it is given 10. New node of next. What is nn of next? This should be 100, which is, can I say, head node value? Nn of next is nothing but head node, which is 100 is connected. Now the thing is, here to this one, 100 to the previous, it's not 300. Now it should be nn, right? So 100 means where it is head node. So head of previous is equals to nn. That means this is nn, which is the node address. Now this is also finished. This is also finished. Now this one, what you need to write here? This should be nn of previous should be the last node, right? Which is a tail node we have, right? So which is the tail node address? So nn of previous equals to tail node. And one more thing you need to write. This is tail node, which is equals to 300. This is also over 300. But what about this tail of next? This is should be current node. So tail of next is equals to nn, current node. And finally, once it is done, head node value should be updated to the new node. So head is equals to nn. It should be last one. You need to make it. You should not make it at the initial. You will get some discrepancy here. So all these things I want to write here. You can see first thing what I'm thinking is nn of next should become head node. I mean, whatever the head node value, nn of next, first this one, this is fine. Now head of previous, what is head of previous is equals to what? Nn, that is what. See, if you compare with the double linked list, you can easily understand what are the minute changes which we need to do. So head of previous, that means this value, it is connected. Now nn of previous will become the tail node, whatever the tail node we have, and next tail of next. So tail of the last node. Why? Because it's a circular. So tail of next is equals to nn. Yes, current node. Now finally, what is a head node will be updated. At the beginning means head node will be updated to nn. So this is what you can do. Anyway, we'll check it out whether it is absolutely fine or not. We need to check it out, right? So once it is written, once again we can go why you have written nn of next. I'll try to write it why we have written each and every line. So nn of next equals to head means this part nn of next, head of previous, this part we updated, nn of previous, this part we updated, tail of next, this last node value updated, head equals to nn, this value updated. So like this we made updations of each and everything. Now after making this update, we'll try to go for one more thing, which is display, whether it is working properly or not. Through display we'll check it out. So we'll try to write what is display function here, display and break, and I'll implement that display function. So I'm writing, which is of course similar, but the thing you need to observe. Now how can you start? Anyway, you need to start from the head node first, but where you want to stop. It's a circular, right? There is nothing like tail of next is equals null. It is again going to the head node, right? So that is what you need to check it out clearly. Anyway, I need to take a struct temporary node to traverse the linked list, where it is starting from the first node, head node, temp equals to head, which has to start. Now you can see how you need to traverse. You want to print each and everything. Of course, I'll write a special case, that is if head is equals to null, list is empty, so nothing to print. Printf list is empty. Now we see, now we'll check it out. If head equals null, print the list is empty. Otherwise what you need to do? Else if it is not, now you need to go for each and everything, each and every element in the linked list starting from the head node. Anyway, temp is head, while, yeah, this condition is very most important. You are going each and everything while temp is not equals to what can I keep it. So temp starts from here, from this node. Next temp of next might be, anyway it will print the data, and next temp it goes. Now how can you say that it is while? Now I'll write like this. You can see, of course, many ways. Temp of previous, which is equals to tail. Let me check it out with this. What my intention is, temp goes like this from here to here, here to here, tail. Now here temp of, what is temp of next? What is temp of next? Anyway, every time I'll go, what is temp of next? 100. It comes to here. Now every time it is checking what is temp of previous here. Temp of previous, what is here? Tail. So then I have to stop. So that means one cycle is over. That's what. And you can see, I'll printf %ld. I want to print what is the temp of data. So anyway, temp equals temp of next, which we want to write here. Temp equals to temp of next. So something like this we need to write, else part it's finished. So let us go with the execution part, this one, whether we'll get the correct answer or any mistakes are there, we'll see. Yeah, I'm checking the braces. Is it a while loop? Yeah, main, that is main is not closed till now. So now I close the main function. Yeah, spelling mistake here. It's insert underscore begin. I uppercase I have given. I want to go lowercase as C is a case sensitive. Insert I should be the lowercase. Yeah, now let us see the display part initially. Of course, the list is empty. We'll try with 1. Create, enter a value 20. So the display part, you can see there is a mistake. So if I give 3, it's not going for the display part. We'll see. So I'll write while temp is not equals tail, that means it goes till the last, and when you go till the last you are missing the last node, right? So that's why I'll print the last node once. So this is what you can make it extra, or else with do while loop you can write it easily. So I want to print it 2 times, I want to print it like this. So this is a one way of writing. I'll write here, you can see in printf %d comma tail of data, or else when temp equals tail, temp of data also, it's absolutely fine. Or else you can write it do while also. Anyway, we'll see first this output whether we'll get the answer for this one or not. So I want to create a node 30. Now so you see the display, yes, 30. I want to insert node at the beginning 20. You see the display, yes, 20 30. And I want to insert one more node 10. That's at the beginning, yes, 10 20 30. This is what you can make it. Why? Because you are going till the last tail. When it is tail, it is coming out, you are missing that last node. So that's why I have written that the last statement, which is printf %ld tail of data. Or if you want to write with do while also, you can write. So what is the do while statement means? So here you need to write, first you need to print what is temp of data. First you need to print it temp equals temp of next, while when you have to stop your temp is not equals head, then you have to continue this part, and when both are equal, then you have to stop. That means one cycle will be over. This is also perfectly fine. You can see this output also. Yeah, 120, you see the display part, yes, perfectly fine. And I want to insert 40, yes, you see the display part. I want to insert 50, you see the display part like this. I want to insert one more 60, you see the display part. So like this, easily you can insert the nodes at the beginning in the circular linked list. So this is about how you can insert the node at the beginning in the circular linked list. So those who are writing, they can write the code, they can execute, find the errors. I'll show the entire program.